the features about that, if I talk about that, I get GPIO ports and timer, and also analog digital converter, and also serial connection block. And I talked about general GPIO ports, which mean general purpose input output ports. Just already talked about that, and I was in the timer section, and I just talked about three separate functions there. So what are those? First one is um, inter- internal timer function, and the second one is input capture function. I just talked about both of them. So internal timer function means it just count out up to um, one particular special time period, and then it just triggered the microcontroller on that one special moment. Likewise like that. So input capture function means it just capture the rising edges and falling edges of the input signal, and it just helps to find out the number of pulses, and also it just helps to find out the time period between pulses. So that's it up to now. So I just got distracted with the moment when somebody in the live just commented down that they need to find my Insta ID. Just of course I have a separate YouTube account, and you guys can follow me there, because I just post every day study vlogs and day vlogs there. And I just has YouTube, Facebook, and Instagram separate same kind three different YouTube, Facebook, and Instagrams there. So you can just follow me there. I just posted the post in my YouTube post. So if you guys are interested in following me, you can just follow with me there. This is just a separate YouTube account of mine. Yeah, let's just move on with it. So if I get the comment again, just to know my Insta ID, you guys can just go towards my YouTube post and find my Facebook page, and there you can find the same similar Insta account also, and also you can search for my YouTube account there. This is just a separate YouTube account. I have separate three different things, so you can find that out. So I hope I will not I won't get again that question about my Insta ID, so you can just find that out. Okay, so let's move on with the our topic. So I was talking about the timer function, and in there I was just talking about internal time function, and also input capture function. So and the next I was just talking about this. So what I want to say is PWM. So what is PWM? PWM is pulse width modulation function. So to be honest, I'm just learning it with you guys. So PWM means what? I will just first learn it and then tell you guys what. And if you guys are here, and you can just you can just search my Facebook and Instagram accounts from my YouTube post. Yeah, if you are interested about my day vlogs and study vlogs. Yeah, I just told here because somebody asked me in the comment section all the time about my Insta ID and everything. So yeah, I hope you guys are no more curious. You guys can find my YouTube post, find from my YouTube post. Yeah. So yeah, what is fault with modulation is it just do this thing, which means it can do this, which means it can change the time period. It stays as high value, and it stays as low value. So that is what pulse width modulation do. It has the ability to change the time period that it stays as high value, also the low value. So the pulse, pulse width modulation technique used to control the speed of a motor and also the brightness of LED type of things. Okay, I hope that I'm okay with now with the timer function of the LED. So yeah, three different functions for our internal timer function and also internal timer function, and then input capture function, and then PWM. PWM is it has the ability to the change the time period where it stays in a high and also low. So uh, yeah, I just talked about the function of the timers. Now let's just talk about the use of timers. Use of timers, what are they in a microcontroller? So it is obvious timers used to count time, right? So in here also, in a microcontroller, the timer used to count time. uh, Hi. And so this used to count time. So and they are telling about something. A microcontroller operates on a clock signal supplied by a crystal or ceramic oscillator. I don't know what is that. I don't understand it. So yeah, what is a crystal or ceramic oscillator? Let's just find that out together. I'm just putting this to ChatGPT and I will tell you what ChatGPT told me. What is a crystal or ceramic oscillator? Well, I will tell you. If you guys know that, let me know before I find that out through ChatGPT. Okay. Yeah. If we use a microcontroller and and we use timer module, and if we need a timer module and normally microcontroller gets input, right? So input signal, we should provide some kind of clock pulses, all right, as input to the microcontroller. So basically most of the time um, people use crystal oscillator or ceramic resonator to put that, like provide this pulses. It is like basically like a clock. It is like a clock, which means it just provide clock pulses. So crystal oscillators and ceramic resonators are there, but they have mentioned some specialties of them. um, it is not necessary to study all those things, but for the knowledge I will read it and I will tell you. So crystal oscillator means a quartz crystal. So it has made from quartz crystal, obviously, and in there the accuracy is very high, and and it can measure the time very it can measure the time very well. And like it used in a time, in a place where the milliseconds and every tiny bit of time is need to be correct in some kind of scenarios. The very small time period should be like it should go like very very small amount of time should be measured very correctly in some kind of scenario. So crystal oscillators are used in that type of scenarios. So normally crystal oscillators are very expensive, and uh, normally when we connect crystal oscillators to a microcontroller, they have mentioned that we need to add capacitors all together with it, and and this, and this just takes some time to start working. That is what they said. Yeah, I don't know what else. This is what ChatGPT said. So what is about ceramic resonator? As I said, crystal oscillator is has made using quartz quartz crystal, and obviously with the name, according to the name you can understand what has using what the ceramic resonators has made. Of course ceramic resonators has made using ceramic, and also compared to the crystal oscillator, the accuracy is very compared to ceramic crystal oscillator, ceramic resonator accuracy is low, but generally in a scenarios where produce some kids toys and some appliances that we use in our home, we use ceramic resonators, and because ceramic resonators are very cheap and it is very affordable compared to crystal oscillators. So normally in a kid's toy we don't need to measure the time in a very like up to very small time. It is not necessary, like the change of a 1 second is, it just doesn't matter. So I mean 1 millisecond, it doesn't matter. So we use that type of things in a uh, ceramic resonator. So yeah, thank you for the hearts. And in ceramic resonators, it has built-in capacitors, and I told you previously in crystal oscillators, it should we should, when we connect a microcontroller and um, crystal oscillator together, we should connect capacitors also, because I think for some purposes, I don't remember the reasons. I think uh, yeah, there can be reason, I don't remember. I already learned those things, but I don't remember it. Yeah. So we should connect capacitors externally when we connect crystal oscillators, but when we connect ceramic resonators, we don't need to connect capacitors because they have built-in capacitors. Ceramic resonators has built-in capacitors, and also uh, it just has two pins, and it just can directly connect to microcontroller, and uh, it just uh, start working on the time it just connect to the microcontroller. But crystal oscillator takes some time. So that's what I get to know about the crystal oscillator. So I just went from this. So I will show you my lecture slide. uh, First of all, yeah, now I can show you it. This is my lecture slide. I need to study this. I hope my colleges don't find me find me, because I feel very embraced. Yeah. Um. Yeah. A microcontroller operates on a clock signal supplied by crystal or ceramic oscillator. So these are the two words that I just explained. Only because of these two words that I just went to ChatGPT and learned everything. These two are not necessary, but knowing it, it makes good. Yeah. So yeah, that's it. So normally crystalline ceramic oscillators are used to get inputs to the microcontroller, input pulses. So it is like a clock. It is like a clock. It just generates clock signals. Yeah. So in general, timers embedded in microcontrollers use their clock signal to count the time. It is obvious. Normally timers used to count time, right? And then the non-chip, number of on-chip timers, the time unit used as the reference of the timers, and the function of timers vary depending on the microcontroller. I don't understand that. What is that? It seems very complex. The number of on-chip timers, the time unit used as the reference of timers, and the function of timers vary depending on the microcontroller code. Okay, I got it, I think. It means that the number of chip times, which means there can be different number of chips in a timer, right? So it can be several number of timer chips. As I understand, I don't know. Yeah, I think so. The number of on-chip timers differ from one microcontroller to another. So some microcontrollers may have several number of timers, and some has only one. Likewise. That's what I got to know. I understood only that, so maybe it is wrong or not, but that's what I understood. If you guys know it, please let me down in the comments, because I can understand it, because I'm not a master. Yeah. And also the time unit used as a reference of timers. They're talking about something called reference or something like that. Um, yeah, they are talking about something reference clock. So I don't know what is going on there, but like the time unit in the reference timer, it's also different. Like they are just talking about that these three things are differ from one microcontroller to another. That's they are explaining. But what are those things? Are the things that I not understand. So they are just talking about some reference of the timers, and maybe this is a reference clock. Like according to it, other clock pulses should go something like that, I think. So the measurement, the unit of this time signal differ from one microcontroller to another. That's what I got to understand. So, and also the function of timer vary, I already talked about three different functions of the microcontroller. So what are those? um, uh, internal way internal timer function, input capture function, and also PWM. So we can insert all three functions, and also we can insert only one. So all, like, it just differ from one microcontroller to another. Like what kind of functions are in the microcontroller and what are the not in the microcontroller. Alright, I'm completed talking about microcontroller time part. Now I'm going to talk about AD, um, use of AD converters, which means analog to digital converter. Alright, so this is obvious because normally in a microcontroller they get inputs from different sensors, some timers. Yeah, we use different sensors, some kind of things. So normally those are voltage values we input, and also they are